Now today we'll discuss chemical property. Okay, now today we'll discuss chemical properties of part 2. Last class we have done part 1. So today it is part 2. Remember, again I'm saying alkane topic is easy, hydrocarbon topic, but it will help you to understand the basics of this entire organic chemistry. Because these things will again come in some other topic in some other form. Okay, this combustion related. When alkanes are heated in presence of air or O2, it oxidizes to carbon dioxide and water. This is highly exothermic reaction, right? What is exothermic reaction? We discuss endothermic, exothermic. Exothermic, where energy is released. Exothermic is energy is released. Delta H will be negative for that. Hence, it is used as a fuel. In fact, many families in the village side are still using methane and other thing as a main fuel thing. Like combustion reaction. Remember, it is a full combustion, full 2 moles of oxygen we are giving. Not limited supply of oxygen. So that we have to understand. Supply of oxygen is important here. So 2 moles of oxygen is available for each 1 mole of methane. Then finally CO2 and water will be formed. So this is a basic reaction. CH4 plus 2O2, CO2 plus 2H2. Delta H is negative. Negative means how much energy is released. So 890 kilojoule per mole. This much energy is released. We are getting this much of energy. So if 1 mole of methane will be burned, we get 890 kilojoules of energy out of this reaction. So general combustion reaction for any alkane, we can write like this. Okay. In this one, this reaction, suppose you are forgetting any time, there is one trick to remember it. Like when you can write CnH2n plus 2, which is a general reaction for alkane, plus O2. We don't know how much O2 we need, but we know that CO2 will be there and water will be there. Now CO2, how many? So NCO2. This is Cn. So we'll write this as NCO2. Then water, 2n plus 2. So here 2n plus 2, 2 into n plus 1. So we'll balance hydrogen, 2n plus 1. 2 is already there. So how much we'll get? N plus 1. So first we'll balance carbon. Then we'll balance hydrogen. At last, we can see that oxygen requirement is this side. It is coming as 2n plus n plus 1 from here, which is nothing but 3n plus 1 oxygen. Or we can say 3n plus 1 by 2 oxygen, because 2 atoms will be attached in O2. Okay, so by 2 we can put it. That is what exactly it is given here. So 3n plus 1 by 2 O2. So this is a general combustion reaction for alkane. CnH2n plus 2 plus Cn 3n plus 1 by 2 O2, NCO2 plus n plus 1 H2. So this is a general combustion reaction for alkane that we have to remember. Now any doubt anyone? Remember, again I am telling, balancing carbon first. First carbon balancing, then hydrogen balancing, and at last oxygen balancing. At last oxygen balancing. So if you balance oxygen, it will come 3n plus 1 by 2. Okay, so this is the way we can balance the chemical reaction. If you forget in the exam that how many moles will be required and other thing, then we can balance quickly and then we can use this. Better is to remember the formula of this. If n equal to 4, C4H10, n equal to 4. So 3 into 4, 12 plus 1, 13, 13 by 2 oxygen. Directly we can do it. Remember, this is full combustion reaction. Oxygen is available in sufficient amount. Now suppose it is incomplete combustion. Now in which case we'll talk about incomplete combustion. Suppose oxygen is not available, limited amount of oxygen is available. What we need, that much oxygen is not available. Some less amount is available. With respect to the number of moles of methane, number of oxygen is limited. So in that case, it can be in this also. Plus remember that carbon and water is formed here. Here, temperature, pressure and catalyst also plays a good role here. So incomplete combustion of methane, carbon black is found, which is used in ink. black pigments and filter. So incomplete combustion of methane, remember that, carbon black is formed. So it's one is complete combustion, oxygen is available fully, right? Then of course CO2 and water is formed. If it is incomplete combustion of methane, carbon black will be formed, which can be used of course in ink and black pigment and filters. So the main point which you have to remember is alkane on heating with limited supply of oxygen or air at high pressure and in presence of catalyst give different products. Now you can see that. Methane itself we have discussed. Copper 523 Kelvin. 100 atm pressure. 100 atm pressure is how many? 100 times than atmospheric pressure. 1 atm is atmospheric pressure. We are assuming general in physics also. 100 atm. So it is 100 times more. Methyl alcohol, methanol, right? So see this reaction. Now you can see this is the third one. For methane, we discussed first one CO2 water, right? We discussed that CH4 plus O2. This will give us CO2 plus water. Second one CH4 unbalanced. I'm writing plus oxygen, carbon plus water. Now this is third one. But this time we are using catalyst also. High pressure, 100 atm pressure, not normal pressure, 100 atm pressure. So methanol or methyl alcohol, which is injurious to health, toxic compound is formed. Second one, again catalyst is now MO2O3, heat, methanol, aldehyde group, we are formed. So this is the fourth compound. We can see here that as we are changing the catalyst, we are getting different product. Now in the exam it can be asked, because everyone will think, okay, CO2 and water we have to write. Methanol will be one of the options. So you have to remember the catalyst changes, the product can change. We have to look at what is the catalyst. Then ethane, 2 molecule, again 3 CO2, heated, CH3CO2, Mn, ethanoic acid, acetic acid is formed. Again, plus water. Water is used as a balancing element. We can add always to balance it also the reaction. So acid is also formed. So depending upon the catalyst, depending upon what catalyst and what pressure we are using, we saw that we are getting alcohol, we are getting aldehyde, we are getting acid. Before that we discussed carbon dioxide. Before that we discussed even carbon. So all possible product is there. And that's what we have to remember. Similarly, this is a 3-degree carbon, 2-methyl propane. Three-degree hydrogen, KMnO4, oxidation, OH is formed. So H is replaced by OH, 3-degree alcohol. 3-degree alcohol. In GOC we discussed if a OH is connected with a carbon which is connected with 3 other carbon, then it is 3 degree. So this is 3-degree alcohol. Okay, because the carbon is 3 degree and OH is connected with that carbon. So where OH is connected, that decide 1 degree or 2 degree or 3 degree. If it is CH2OH, this is 1 degree alcohol. Okay, CHOH, 2 degree alcohol. This is COH. This is 3 degree alcohol. So 3 degree alcohol is formed here, right? 3 degree alcohol is formed here. Again, methyl cyclohexane. Remember that here CH3 is there. Those who are not understanding, CH3 is there. KMnO4. Again, OH is attached with here. One methyl cyclohexanol. So whenever we see that oxidation, control oxidation, if anything like this, we have to be careful in answering that MCQ. We should not directly jump to the conclusion this will be the answer because we studied CO2 and water. Remember, we have to see what is given, what is the pressure, what is the catalyst, what is the oxidizing agent we are using. Based on everything, all factors we have to do. Now, this one we discussed while doing the PPT on control oxidation of ethane in presence of manganese acetate. Manganese acetate, what it produces? What it produces? Manganese acetate. We discussed even that acid can also be produced. Acid can also be produced. This was the example for that only. Acetic acid will be produced in this. A number of moles of oxygen required to complete combustion of C4H10. Complete combustion. Right? What with the formula we discussed? 3n plus 1 by 2 O2. 3n plus 1 by 2. N is 4 here. So how much it will be? 13 by 2. Right? 13 by 2. So number of moles of oxygen required to complete combustion 13 by 2. So we have to remember this formula. Then let's discuss the part 3, chemical properties, isomerization. Now, normal alkanes or heating in presence of anhydrous AlCl3 HCl gas isomerizes to branch in alkane. This reaction is called isomerization. It is converting itself into branch chain. It is a normal straight chain. Straight chain converted to branch chain. Straight chain is converted to branch chain. So this is isomerization. What is the catalyst we are using? Anhydrous AlCl3 and HCl gas. So in presence of this one, right, isomers, chain isomers will be produced. So isomerization. Normal hexane, all are CH2, CH2 in between. That's what CH4, CH2, anhydrous AlCl3, HA3. You can see one CH3 is coming down. Remember, the name of the compound will change. It will not be hexane because it is branched now. So substituent, it has converted a substituent CH3. Right, of course, naming will start from 1, 2, 3, 4, 5. Okay. So it will be 2-methyl pentane. 2-methyl pentane. Second carbon, methyl has come. So 2-methyl pentane. Then, of course, other product. Because we have to understand one thing here that there are different type of carbon here. This carbon is exactly coming in between. Right? This and this will be same. This and this will be same. So whether CH3 is coming here or here, it doesn't matter. But in between, if it is coming, it is a different product because it will be 3-methyl pentane. So 2-methyl pentane and 3-methyl pentane. Is there any other possible product here that CH3 will come somewhere? Suppose it is coming in the last, then it is going to be same as normal hexane. Both the lasts are same. Both the second last is same. Only the second last and in between will get a different product. So that's what we are getting here, 2-methyl pentane as well as 3-methyl pentane. So any doubt, anyone in this? Now suppose it is having 6 or more carbon atom and it is heated at higher pressure, 10 to 20 atm pressure in presence of V2O5, Cr2O3, MO2O3 over alumina. It will produce benzene and its homologues. This reaction is called aromatization or reforming because aromatic compound it is converting. So it is aromatization or reforming. But remember, for this we need high pressure, we need catalyst, we need high temperature, we need 773 Kelvin, 10 to 20 atm pressure. And in presence of V2O5, Cr2O3, MO2O3 over alumina produces benzene or its homologue. So we need catalyst, we need high temperature, we need high pressure, then only this will be there. So this reaction is called aromatization or reforming. Remember, normal alkane will convert to chain, that to benzene chain. Aromatic compound, it will convert. We can draw the normal hexane like this. And then this catalyst, benzene ring has been formed. So this reaction also is very, very important. From normal hexane, we can convert directly to benzene. Now this will be used as a very good question in case of asking some product, and you have to guess that benzene ring is coming in between. Suppose A gives B, B gives C, and all those type of questions, finding the unknown product. In that case, you have to understand that using these product, this temperature, this pressure, we'll get the benzene ring. Hence, the reaction altogether will be different. So aromatization is there in this. Benzene is formed. Now, next one, when normal heptane is subjected to aromatization, the product is, see, normal heptane is there. So 7. For benzene, we need 6. Right? So 1 is extra. 1 is extra. 1 methyl is extra. So which one we can get? Benzene, we need only 6. So of course, heptane is extra. So it will be B or C, toluene or methyl benzene. Toluene or methyl benzene. So 1 methyl will be there at any position. All position basically will be same only. Right? Any position, 1 methyl will be there. So toluene or methyl benzene will be formed. So normal heptane is subjected to aromatization. The product is toluene or methyl benzene. 2-methyl pentane and 3-methyl pentanes are, what are they basically? Now this is related with GOC. They are chain isomers, they are position isomers, chain and position isomers, they are metamers. What they are? Whether methyl, remember, methyl positioning has been changed, right? Chain is same or different, that you have to find. So what we can say this one? We can say it to be position isomer. Okay. Now, chemical properties of alkane, part 4, reaction with steam. Of course, that temperature of water is high, converts to its steam. In presence of nickel catalyst, remember we are talking about 1000 degrees Celsius. 1000 degrees Celsius, 1273 Kelvin. Okay. Nickel catalyst, it will give carbon monoxide and hydrogen. This is hydrogen gas preparation industrial method. Okay. So CO plus 3H2. Carbon monoxide, hydrogen. Next is pyrolysis or cracking. So higher order alkane will convert to lower order alkanes. Higher alkanes are heating to high temperature, decompose into lower alkane, alkenes, etc. This reaction is called pyrolysis or cracking. Basically, carbon chain is reduced or carbon chain is broken. Okay. The decomposition of higher alkane to a smaller fragment is called pyrolysis. This reaction takes place through the free radical mechanism. Okay. So you can see different type of products are there. Different type of products are there in which we have hydrogen, then C6H12. C6H12 is nothing but CnH2n, alkene. Alkene. C4H8 alkane, C2H6 alkane. Because if you have any doubt, apply the formula. CnH2n plus 2 is for alkane. CnH2n is for alkene. There will be one double bond somewhere. Okay, and CnH2n minus 2. There will be a triple bond, alkyne. So we have a mix of alkane and alkene product here. Okay, C3H6, C2H4, CH4, all this mixing product we are getting by cracking pyrolysis. Similarly, we have 12 carbon, dodecane, PT, PDNI, 973 Kelvin. Again, it is cracking. Heptane, pentene, double bond, C5H10, and other product will be there. Pyrolysis is used to prepare petrol or kerosene from gasoline. Okay. So this is useful reaction. Ethane under nitration gives. Remember, it is substitution product we discussed in the reaction, chemical reaction. Under nitration, what will be? One hydrogen will be replaced by NO2. So C2H5NO2. Okay. Propane under combustion gives what it will give us. Under combustion, what it will give us. Remember, when they are saying under combustion, we will take normal one. Okay, unless there is something, we will take normal one. So what it will give? CO2, water, and heat. Normal combustion. They should specify if any other thing they want. They have to specify catalyst or higher temperature or something. If they are not specifying, we'll take normal temperature. That they are asking normal temperature. So propane under combustion gives CO2, water, and heat. Halogenation is, what is halogenation? Halogen has to be added. Already we discussed, okay, what type of reaction it is. We discussed already in the beginning itself that it is free radical reaction. This halogenation is free radical reaction. So option C will be correct option. Pyrolysis involves. What it involves? Just think it and try to answer it. Then I'll. Just now we discussed pyrolysis is also called as cracking, right? Dehydrogenation. Dehydrogenation. Hydrogen has been removed, but I think more importantly, we'll go for cracking, not dehydrate. Dehydrogenation is removal of hydrogen only. Pyrolysis involves even breaking of the chain. So option B will be correct, not C. So you can rectify. Ethane under dehydrogenation. Hydrogen has been removed from ethane. Now you can see the formula itself. For a hydrocarbon, it is CnH2n plus 2. Now if hydrogen is removed, it can be this or it can be this, right? If hydrogen is removed, because both is having less hydrogen than any alkane. So what will happen? But remember, carbon chain is unaffected. Carbon chain is not changing. 2 carbon will be 2 carbon only. When hydrogen has been removed, dehydrogenation. Hydrogenation is adding hydrogen. Dehydrogenation is removing hydrogen. So dehydrogenation, removing hydrogen. So if you remove hydrogen, what will be? Ethene will be formed. Okay. Carbon chain will be untouched. Length of the carbon chain will be same. Okay, so with this reaction is completed for alkane. Then we'll discuss some MCQs in next class.